Okay, let's unpack this. We are diving deep into a pretty specialized area today, therapeutic endoscopy during emergencies.
Right.
And our whole focus really is built around understanding one specific kind of incredible last-ditch tool. We're pulling our info straight from Dr. G.S. Raju's YouTube series.
Yeah, the one on hemostatic devices,
Yeah.
specifically his video on hemostatic powder. It's really detailed stuff.
It is. So our mission here is to get into the function and maybe more importantly, the really, really precise setup for this thing called Hemospray.
Exactly. And what's fascinating is that this isn't step one. This is the salvage technique, It's what you grab when, well, everything else has failed.
Right. So picture this.
Mm-hmm.
A doctor is doing an endoscopy, maybe looking at an ulcer, and suddenly, boom, massive bleeding, uncontrollable. They try the usual stuff in injecting epinephrine, maybe trying to slap a clip on the vessel, using a bipolar probe to cauterize it.
Standard hemostasis techniques.
Exactly, but maybe the vessel's too big, or they can't quite see the exact source, or it's just bleeding too much. It's a crisis moment.
And that's precisely where Hemospray comes in. Dr. Raju is super clear about this. It is not a first-line treatment.
Definitely not routine.
No. It's that specialized tool for when the traditional methods just aren't cutting it. It's like, calling in the heavy artillery for a fire that's out of control.
So let's look at the tool itself. Fundamentally, Hemospray is just this special powder, right? How does this powder actually work? What's it doing?
Well, it's basically a mineral-based powder. They spray it over the bleeding vessel. And the moment it hits that wet environment blood, fluid, it becomes incredibly hydrophilic.
Meaning it just sucks up water?
Instantly. Yeah, it actively seeks water. And the source explains this interaction really speeds up the body's own clotting process, the natural cascade.
Okay.
So it forms this thick, immediate layer, like a mechanical plug, a coagulum, right over the bleeding site, and achieves hemostasis pretty much instantly.
That sounds almost too easy, like spray and fix. Perfect solution.
Huh.
But I get the feeling that's where the story gets complicated. That simplicity is maybe a bit misleading.
Completely misleading. Yeah, absolutely. Because that simple fix, it's critically temporary. This is probably the biggest takeaway from Dr. Raju's explanation.
Temporary how?
Once you get control, that hemostasis, it typically only lasts about 48 hours, maybe a couple of days, tops.
Wait, only 2 days?
Yeah.
Seriously?
Yeah.
That's not a fix at all. That's just hitting pause.
Exactly. And the huge implication, the thing he stresses, is that the bleeding is highly likely to restart.
Wow. Okay, so if you've just stopped this catastrophic bleed, that 2-day window suddenly becomes this massive ticking clock for the whole medical team.
It absolutely does.
What are they doing in those 48 hours? What's the race against?
They're racing to get to what's called definitive therapy. Hemospray is just a bridge. It bought the patient time, maybe time to stabilize and get blood transfusions.
And time for the team to figure out a real permanent fix.
Precisely. Time to plan that permanent solution.
And what does that definitive therapy actually look like? I mean, what are the options?
Well, it really depends on what caused the bleeding in the first place, the thing that was maybe hidden by all the blood before.
Right.
If they can now see the source clearly after the Hemospray worked, maybe it's another endoscopy to place clips more securely. Or it could escalate, significantly.
Surgery.
Could be surgery. Or very often, especially with internal GI bleeds, it means getting interventional radiology involved. They can do targeted embolization.
But just like?
They thread a tiny catheter, usually through an artery in the leg, all the way up to the vessel that's feeding the bleeding lesion, and they block it off physically. Plug the pipe, essentially.
Okay, so in those 2 days, the patient's likely in the ICU, can't leave, and everyone knows that powder plug is just temporary, it's going to degrade.
Yeah, the clock is definitely ticking.
That urgency must just ratchet up the stress of the initial procedure itself.
Mm.
Which brings us to maybe the most counterintuitive part. The setup. This is where it gets really interesting, you said.
Yeah, madness might be a good word, actually. You're in the middle of this massive bleed, right? There's blood, digestive juices, maybe irrigation fluid the endoscopist used.
It's a liquid mess.
Totally. A
Yeah.
thoroughly liquid environment. But this Hemospray device, it has one absolute non-negotiable rule.
Which is?
The delivery catheter must be kept completely dry.
Dry. In the middle of all that fluid, why? What happens if it gets wet?
Because that powder is so good at clotting, so hydrophilic, that if even a tiny droplet of moisture gets inside that long, thin delivery catheter,
It clumps up.
instantly, the powder clumps turns into this solid plug like concrete. The catheter clogs right up and the device is useless, just like that.
Wow.
and you've potentially just lost your last chance to stop that bleed.
That sounds like a crazy engineering challenge. So how on earth does the team looking at this, watery chaos on the monitor manage to keep this thin tube perfectly dry while they're pushing it, what, like 10, 15 feet down the endoscope channel?
It takes this constant active process and incredible coordination. Dr. Raju points out you need a big syringe, like a large bore syringe, filled only with air.
There. Okay.
And that air is used to continuously flush the catheter as it's being pushed down. You have to keep pushing air through it.
So like creating a constant internal breeze blowing outwards.
Exactly. Actively blowing any potential moisture back out the way it came. And that flushing, it can't stop, not even for a second while they're advancing it.
So you've got the endoscopist steering the scope and pushing the catheter, and someone else, an assistant maybe, constantly pushing the air syringe plunger,
Right.
all while remembering the catheter itself is apparently quite delicate.
Yeah, that's another layer. The source mentions it's a through-the-scope catheter,
Right.
naturally, but it's designed to be a little bit softer than other catheters they might use.
Why softer?
Probably for flexibility to navigate turns, but the downside is it makes it easier to kink. So the endoscopist has to use these small, gentle moves, as Dr. Raju puts it, while pushing it forward. It's this real delicate balance.
Continuous air pressure, steady forward movement, but super gentle so it doesn't fold or kink. Because a kink would block it too, right?
Just like moisture, yeah. A kink means game over for that catheter.
Okay, but here's the part of the procedure that I find just wild. The thing that seems to go against every instinct you'd have in that emergency situation.
Let me guess. The suctioning.
Exactly. The endoscopist has to actively stop themselves from hitting the suction button on the scope.
Yeah, that's the real operational sacrifice, isn't it? When you're facing a massive bleed, what's the first thing you want to do?
Clear the view. Suck out the blood so you can see.
Right. Hit the suction pedal. But here, in this very specific situation, doing that could be fatal to the procedure.
How so?
Suctioning creates negative pressure in the scope channel that could easily draw fluid backwards right onto the tip of the Hemospray catheter as it's sitting there waiting to be advanced.
And boom, it gets wet, clogs up before you even fire the powder.
Precisely. So you're making this incredibly tough call in real time.
You're choosing, literally, between getting a slightly clearer view for a second and potentially wrecking the only tool left that might save the patient's life.
Yeah.
That must be intense.
It really highlights the kind of laser focus needed, doesn't it? The whole team has to be completely aligned. Protecting that catheter's dryness is the absolute top priority, even if it means working with, let's say, slightly suboptimal visibility for moments.
Okay, so let's assume they pull it off. They navigate the soft catheter down, they keep the air flushing constantly, they avoid kinking it, they resist the urge to suction. The catheter tip is finally where it needs to be, near the bleeding.
Yeah.
Now what? Time to deploy the powder.
Right. So once the tip is positioned correctly and they're sure it's dry, it gets connected, and the source says tightly connected to the main Hemospray device handle.
And this handle needs power, a propellant.
Yeah, the whole system is powered by an external cylinder of carbon dioxide, CO2.
CO2. Why specifically CO2? They were just using air to flush the catheter. Why not just use compressed air to push the powder too?
That's a really good point. It comes down to the physics and the need for absolute dryness right at the end. CO2 is stored under very high pressure, which gives you a powerful, rapid pulse.
Okay, power.
But maybe more importantly, CO2 is an inert gas, and it's incredibly dry. When that high-pressure CO2 expands rapidly as it goes through the nozzle, it has a significant cooling and drying effect.
Like those compressed air dusters, they get cold.
Exactly like that. So it provides one final blast of dryness right at the exit point, vaporizing any potential tiny bit of condensation right before the powder shoots out. It's like the ultimate guarantee the powder stays perfectly dry until the very last millisecond.
So the CO2 is like the final insurance policy against moisture. Plus, it gives the push needed. Got it. Now, how do they actually trigger it? There's a specific sequence with knobs, isn't there?
Yes, precision again. It's 2 steps with controls usually colored red. First, you activate the CO2 cylinder itself, pressurize the system. You turn the red knob, usually clockwise, until it stalks. That opens the tank flow.
Okay, system pressurized.
Second, you open the pathway to the catheter. There's usually a red valve or lever. You turn that in the direction of the catheter tubing. Now the pressurized CO2 is ready to go down the line.
And then the endoscopist actually fires it.
Yep. They press the trigger, usually a red button on the handle, but only for a very short burst. Dr. Raju says just 1 to 2 seconds.
That quick.
Yeah, it's a pulse. That quick blast of CO2 is enough to drive a cloud of the powder through the catheter and onto the bleeding lesion.
And how do they apply it? Just one shot.
Usually not. The source gives a good example. Treating a large lesion where the bleeding was massive, and maybe they couldn't even pinpoint the exact vessel. It was more like a diffuse ooze from a large area.
So you need to cover the whole area, like painting it.
Kind of, yeah. They might apply one puff, assess then maybe some more puffs, to try and blanket the entire bleeding surface. Coat the whole region to get control.
But given all the challenges with setup, we have to come back to that failure point. Clogging. It must happen sometimes, despite everything.
Oh, absolutely. It's described as the most common failure. Even with all those careful steps, the catheter just clogs.
So what happens then? Is it just over?
Well, thankfully, the designers anticipated this. The source notes that the Hemospray kit usually comes with an additional catheter, a spare.
Oh, that's huge. A backup plan.
It is a huge benefit, but, it doesn't really lessen the stress of the moment. It means the team has to quickly disconnect the clogged catheter, discard it.
And start the whole nerve-wracking process all over again.
Exactly. Back to square one under the same crisis conditions, gently pushing the new soft catheter down, keeping it dry with continuous air, hooking it up, turning the knobs, firing the trigger, all while the patient is potentially still bleeding or at immediate risk of the bleeding restarting.
Wow. The ability of a medical team to execute that kind of really meticulous, almost counterintuitive sequence in the middle of an active emergency is pretty astounding when you break it down.
It really is. We've seen how this technology, which sounds simple, just spray powder, actually demands this intense procedural precision just to make it work.
Absolutely. We've seen Hemospray acting like that firefighter, as you said, putting out the immediate fire, buying that crucial pause. And we've really highlighted that tension between needing meticulous control, the dryness, the gentleness, and the sheer chaos of the situation the patient is in.
And it's clear how valuable it can be in those really tough spots, especially like the example when you can't even be sure exactly where the bleeding is coming from, when clipping or injecting just isn't an option.
It's definitely an indispensable tool in that last resort scenario.
No doubt.
So, wrapping this up, what does this all mean for you listening?
Well, the tech itself is pretty impressive for stopping a crisis in its tracks.
But it really underscores that stopping the bleed is just the start of the battle, isn't it?
Yeah.
Because that fix only lasts a couple of days. That definitive permanent care has to follow quickly.
It's absolutely mandatory.
Which really makes you wonder, doesn't it? What goes on behind the scenes in the hospital during those critical 48 hours? What are the protocols, the communication between departments, the staffing needed while that clock is ticking down and the team is scrambling to find and implement that permanent fix before the temporary one fails? That's something for you to mull over.